Good morning, students. So today we are going to discuss about some water quality indicators. So the first one is electrical conductivity. So what is electrical conductivity? It is mainly the ability to conduct electricity. If water contain high concentration of ions, then that water can conduct electricity. Thus we can say conductivity is a measure of the dissolved solid particles present in water. This measurement can be used to detect pollution discharges with high ionic strength. Now, what is salinity? It is a measure of salts in water. Dissolved salts increase both salinity as well as conductivity. So, both are interrelated. As conductivity is dependent on the water source, it can indicate groundwater seepage or sewage leak. Next one is turbidity. See, pure water is always colorless. Then what is turbidity? It is a measure of light transmission through water. The greater is the number of suspended particles, the greater is the turbidity, as the particles try to resist the movement of light. Suppose this is the glass of water, which consists of suspended particles. So these particles will try to resist the transmission of light. So from here we can say that greater the number of particles, the greater will be the turbidity. So these particles can be an organic or inorganic. Inorganic, it can be microbes, algae, animal detritus, etc. Or in inorganic form it can be silt, clay, etc. High turbidity is also indicative of bacterial contamination. Turbidity of water can be measured through turbidimeter. Next one is pH. So pH is a measure of concentration of H plus ion, that is hydrogen ion. It mainly tells us about how much the water is acidic or basic. The pH of water ideally should be 7, which is actually neutral. So pH of any water body depends on the chemical characteristics of the surrounding land and its water inputs. Rather than that, pH also has some effect on the solubility of organic matter, minerals, and metals. In an acidic medium, metals may dissolve and be absorbed by living organisms. Now let's see how pH in water affects both biological and chemical processes. Some chemical reaction of narrow pH range is sometimes necessary for the survival of some aquatic organisms. But the pH below 4.5 and above 9.5 are usually lethal to aquatic organisms as it damages gills, fins, or exoskeleton of those organisms. For example, the low value can increase the solubility of mercury, whereas high value may convert less toxic ammonia to more toxic form. Next is dissolved oxygen. So dissolved oxygen in water is very much important for aquatic organism. Some species require high dissolved oxygen, whereas some aquatic organism can survive in low concentration of dissolved oxygen as well. Low level of dissolved oxygen acts as an indicator of water pollution, whereas aquatic plants and algae play major role in adding oxygen into the water during photosynthesis. Less dissolved oxygen in water can cause death of certain species, reduction in growth, failure of eggs to hatch or larvae to survive. Cold water can hold much dissolved oxygen than warm or polluted water. Thus, dissolved oxygen also acts as an indicator to check the pollution level of water. Next is temperature. So temperature also play a very vital role in the ecosystem. An increase in temperature reduces the solubility of dissolved oxygen, which is essential for respiration of aquatic plants and animals. The rate of chemical reactions is also affected by the temperature of water. As higher the temperature, the quicker is the rate of chemical reactions. Biological processes are also dependent on the temperature of the water, as the change in water temperature may act as a signal for fish to swarm or insects to emerge. Next is hardness of water. Hard water does not form lather with soap, as it caused by dissolved salt of calcium and magnesium. Good quality of water should not have hardness more than 270 mg per liter. But hard water is better than soft water because soft water may be corrosive depending on pH, alkalinity, and level of dissolved oxygen. Next one is nitrate in water. So, from where does the level of nitrate increase in water? It is from the fertilizers which is not taken by the crops and the excess nitrate which just enter into the water body as runoff. These excess nitrate are the indicator of algal bloom, eutrophication that takes place in presence of surplus nutrients present in water. The decomposition of this algal matter by the bacteria takes up dissolved oxygen, adversely affecting the other aquatic organism. So excess nitrate in water cause loss of aquatic life. Next is sulphate in water. So high concentration of sulphate in water spoil the taste of water and is responsible for the formation of scales in boilers. Good quality of water should have sulphate more than 250 mg per liter. The last one is fecal waste. Some bacteria even acts as indicator of water pollution. Those are coliform bacteria and streptococci. So they mainly tell us about the contamination of sewage with fecal waste. These bacteria are mainly found in digestive tract of human being and animals. Water contaminated with fecal matter give a cloudy appearance, cause unpleasant odor and increase oxygen demand. So to make the water suitable for drinking, disinfectants are added to the local water treatment plants to kill the microbes. So this is all about the indicator of water pollution. On the next class, we will start from monitoring soil quality.